A stone is dropped from the upper observation decks of the Canadian National Tower, 450 meters above the ground. Find the distance of the stone above the ground level at time t. How long does it take the stone to reach the ground? What is the velocity when it strikes the ground? If the stone is thrown at the speed of 5 meters per second, how long does it take to reach the ground? The CN Tower is 450 meters above the ground level. If a stone is being dropped, when it hits the ground, we want to know the distance above the ground of the stone at any time. So we will let it be height, or d, be the distance above the ground. At the ground level, the distance is 0, or the height is 0. We also want to know the velocity the moment it strikes the ground. Not that it is lying on the ground, but the moment of impact. This is the projectile motion, so we can use the formula h of t equals negative 1/2 gt squared plus v naught t plus s naught, where g is the gravity, v naught is the initial velocity, and s sub 0 is the initial height. In this case, if we let d be the function, then d of t equals negative 1/2. The metric system meters is given, so we would have to use the gravity 9.8 meter per second squared. T is a variable, so we would have to rewrite it. The stone is being dropped, so there is no initial velocity. The velocity is 0 in this case. And the initial height is 450 meters above the ground. Simplifying this, we have negative 4.9 t squared plus 450, and this is the distance above the ground level at any time t. How long does it take the stone to reach the ground? To reach the ground, the height would have to be 0, or the distance would have to be 0. So we set the distance equal to 0. 0 equals negative 4.9 t squared plus 450. In this case, we don't want to factor this because this is not an integer coefficient. But if we solve for t by simply isolating this, we have the square root of 450 over 4.9. We bring the negative 4.9 t squared to the left-hand side to get positive 4.9 t squared. Divided by 4.9 and taking the square root, this is approximately 9.58 seconds. When we take the square root of 2, there's no need to use the negative because the moment we release the stone is when time is 0. So how long does it take the stone to reach the ground? About 9.5 seconds. With what velocity does it strike the ground? To find the velocity, we would need to have the velocity function first. If d of t is negative 4.9 t squared plus 450, then the velocity is the derivative of d. The derivative of negative 4.9 t squared is negative 4.9 times 2t, and the derivative of 450 is simply 0. So the velocity function is negative 9.8 t. The moment it hits the ground is when time is approximately 9.58 seconds. So we plug 9.58 into the velocity. Negative 9.8 times 9.58, we will get roughly negative 93.88 meter per second, or about 94 meters per second. The velocity is negative because the height, or the distance of the stones, is decreasing as it gets close to the ground level. The speed is the absolute value of the velocity, so we would say that the speed is 94 meters per second, where we rounded it. If the stone is thrown with a speed of 5 meters per second, this time it is no longer a free fall. It has the initial velocity, so we would need to update this equation. D of t is now negative 1/2 times 9.8 t squared plus the initial velocity is no longer 0. This time the stone is being thrown, not dropped. Since the stone is being thrown downward, not upward, we would use a negative velocity, which is negative 5. Even though we were given the speed of 5 meters per second, but it is being thrown downward, so the velocity is negative 5 meters per second. Again, the speed is the absolute value of the velocity. That is why it is 5 meters per second. V sub 0 is negative 5. We still need to rewrite t plus S sub 0 is 450. So with an initial velocity, the equation is now negative 4.9 t squared negative 5t plus 450. We want to know how long does it take to reach the ground. It should reach the ground faster because this time it is being thrown. We set this equation equal to 0 and we solve for t. 0 equals negative 4.9 t squared minus 5t plus 450. Using the quadratic formula, t equals negative b plus or minus b squared minus 4 times a, negative 4.9 times c, 450 over 2a, a is negative 4.9. This is the quadratic formula. We will have two solutions. One is negative and one is positive. Plug this into a calculator to obtain the positive solution. We will get 9.087 seconds. So yes, if it is being thrown downward, then it reaches the ground faster, just a little bit faster, about 9 seconds after it is being thrown downward.